Hello everyone. So we are going to start the last part of the topic evaporation. So in the part 4 here we are going to discuss some of the left out instrument which we have detailed or listed in our previous slide. So without wasting any time, let's go to the next instrument. The next instrument, it is the evaporating still. So why the name still it has come? See, this type of evaporator is commonly known as still because why? The evaporating pan which is used here, the evaporating pan is covered here. The evaporating pan where the liquid will be heated, it is covered here and it is connected to a condenser. The evaporating pan, it is covered here. Moreover, this pan, it is connected to a condenser so that the vapor whichever it has produced, you know that when the feed it is put inside the evaporating pan, after heating the fluid it will get evaporated, right? So earlier what happens, earlier in the other instrument, after the process of evaporation, the vapors they are separated by using a cyclone separator, but here the vapors they are condensed because the pan it is covered and the outlet of the pan it is connected to a condenser, right? So there is this vessel, actually there is a vessel similar to the evaporating pan with a cover that connects it to the condenser so that the liquid is distilled off here. I will show you how it is distilled off. So let's see the construction. So it consists of this instrument, it is consists of a jacketed evaporating pan. Jacketed, we all know what is jacketed. So it will have a jacketed evaporating pan with a cylinder cover that connects it to the condenser. So how it looks like, see, so this is the pan, right? This is the evaporating pan. I already told you, we have already discussed in our previous slide regarding the evaporating pan. This is the evaporating pan, right? So this is the inlet for the steam to heat and this is the outlet for the steam and this is the outlet for the condensed steam and condensed gases, right? Now here the feed will be introduced, right? So earlier in the earlier type, here we have an open area for this, right? But now this pan it is connected to a cylindrical vessel and it is covered by a pan, right? This is a pan and this pan it is somehow it is connected to a condenser where the vapors it will come from this side, it will enter in this condenser. While traversing the part of this condenser, it will get cooled because the condenser it will have cold water and finally we are going to get the liquid again, that is the vapor, it will get converted into liquid again, right? So the overall assembly, this assembly it is known as still. Thus this is known as a evaporating still. So the cover is the cover here, see, the cover is clamped with a evaporating pan. This one, it is also clamped with a evaporating pan, just similar to this one, but it is smaller in size, all right? So now see how it works. The dilute liquid which we want to concentrate, right? The dilute liquid it is fed into the steel and covered with, and the cover is clamped. So here we are going to fill the liquid which we want to evaporate. The dilute liquid it will be filled and finally it is fed in the steel and the cover is clamped here. The cover will be clamped, right? The next thing is that the steam will be now introduced into this jacket. The steam, hot steam will be introduced into this jacket. As the steam is carrying the heat it will transfer from this jacket into the liquid inside and it will start heating, right? The next thing is that liquid is evaporated, we know that, right? And condensed in the condenser and here the liquid will be collected. The vapors they will be collected once they will pass to this condenser here, right? So the product, that is the concentrated liquid, is collected to the product outlet. Here you are going to have a product outlet. This is the product outlet as it has come from this chamber, right? This is the product outlet and this is the outlet for the steam, or you can say the cool down steam, and this is the product outlet. Now advantage, it is easy to clean and very easy to maintain. It's a very simple apparatus, right? So allow this equipment to be used for solvent other than water. This instrument can be used for other type of solvent except water. Means you can use organic solvent like ethanol, methanol, butanol, propanol, even hexane, right? Disadvantage is that all liquid is heated all at a time. Here, whatever liquid you are putting here, earlier what happens? The topmost layer it is heated first, right? So evaporation is taking from the topmost layer, but here as it is covered, right, this area is covered by the steam jacket, so all the liquid here present, all the liquid which are present in this area, they get simultaneously heated. Thus the all liquid which are present here, they get simultaneously heated at a time. So the heating surface is limited in this case. Clear? The next one, it is the short tube evaporator. So this is the short tube evaporator. See, this is the calandria. We know that the connection of the calandria. This is the inlet for the steam to be supplied to this tube, right? This is the outlet. This is the outlet for the steam. This is the outlet for the steam, and these are the tubes, right? This is the downtake, right? Downtake means from here the concentrated product will be collected here. The liquid or the liquid which we want to concentrate will be feeded from this side, and this is the liquid level. The liquid level to be maintained always above the calandria, right? And whatever the vapor it forms, it comes out from here and it is allowed to enter the condenser. Thus, first of all, the construction. The evaporator is a cylindrical vessel. As you can see that it is a cylindrical vessel. The lower portion of the vessel, it have the nest of tubes. These are the nest of tube with the liquor inside, right, and steam outside. This assembly, it is known as the calandra. Now the specification of the calandra are as follow. For this instrument, what are the specification of this calandra? So basically you see the tube length is 1 to 2 meter in length. The length of the tube, it is 1 to 2 meter, right? The tube diameter is 40 to 80 millimeter. The diameter of the evaporator, this one, the whole diameter of the evaporator is 2.5 meter. Number of tubes, almost 1000 tubes are present here, right? Now the feed inlet is at the top of the calandra. Here the feed inlet is there. The product outlet at the bottom of the evaporator. Here it is the product outlet. The steam inlet and outlet is this base side of the calandria. This is the steam inlet, this is the steam outlet. Clear? This is the construction of the short tube evaporator. Now you see advantages. The use of tubular calandria, it increases the heating area. Why? You are getting a bigger area, right? It is transversing, the liquid is transversing a huge area, possibly by a factor of 10 to 15 as compared to 10 other external jacketed equipment. Thus here efficiency of heating is more, or heating area is more. Moreover, as the area is more, thus you can say the increasing, or it have a increasing rate of heat transfer. Means you can easily concentrate a product using this type of a short tube evaporator. Next, the condenser and receiver to be attached to run the evaporation under the vacuum with non-aqueous solvent. So here at this point you can attach a condenser. This condenser, once it is attached here, the vapor will go in this side. Once the vapor will go, immediately see the movement is very simple. The vapor they have heated, right? Once the vapor have heated, they get heated, they become light as compared to the liquid. They will fastly move to this area. If this pipe it is connected to a condenser, because they are at a higher temperature, they will always tend to have or tend to go to a region of the lower temperature. So this vapor it will immediately go. This vapor, whatever it has formed here in this region, it will immediately go to the condenser. Once it will immediately go here, what will happen? A area of vacuum it will be created here, area of vacuum, because we all know that the air or the liquid or the vapor in high temperature, they will have a more kinetic energy, so thus they have a tendency to move very fastly, right? Disadvantage of this instrument, since you see the evaporator is this filled to a point above the level of the calandria. This is the liquid which is always placed above the calandria. Thus, a considerable amount of liquid is heated for a long time, as it is always placed above the calandria. About a amount of the liquid, it is heated for a long time in this instrument, and this effect of this continual heating, actually, as it is continuously heated, the liquid, it can be reduced to some extent by removing the concentrated liquid slowly from the outlet at the bottom. Suppose earlier it has reached a region here. Suppose we have initially filled the instrument with the liquid. Earlier the level of the liquid is here. Once we have started heating the liquid, right, the evaporation will take place. It will go in this side. We to immediately open the bottom so that the concentrated product can come out, and the initial layer of the liquid, it will come down slowly and slowly. But remember one thing, that for efficient heating, the liquid should be always in similar to the layer or height of this short tube, right? Next one, disadvantage, it is a very complicated design, so it is very difficult for cleaning as well as for the maintenance, right? The next one, we have the wiped film evaporator. We all know that what is the meaning of wiping is simply a movement of the liquid or anything over a surface, right? So this is, I am showing you the transverse section, TS, transverse section. If you assume a cylinder, suppose there is a cylinder like this, bigger cylinder like this. If we cut it here in a transverse way, I am showing you here the transverse section. So this is the transverse section of a wiped film evaporator. Now you see, the thing is that it is a form of film evaporator. The wiped film evaporator, it is a form of film evaporator coming into increasing use these days. It is very commonly used. This is also known as the wiped film evaporator, also known as the rotary film evaporator. This rotary film evaporator is very much used in pharmaceutical engineering unit operations because it is very helpful in removing the organic solvents and even in preparation of many different particles drug delivery system, right? Now it contains a single short tube of wide diameter. It will have a short tube of wide diameter, right? Better described as a narrow cylinder vessel of 1 to 2 meter in length. So better you can say it is a vessel of 1 to 2 meter in length. Suppose there is a cylindrical vessel, like there is a cylindrical vessel of 1 to 2 meter in length, right? Now it will have a short tube of wide diameter, right? The next thing is that, see, a section across the evaporator is shown here. This section, it is the transverse section, is shown here, where it will be seen that the vessel is surrounded by a heated jacket. This is a heated jacket. Suppose there is a cylinder. If I want to show, suppose arbitrarily there is a cylinder like this, right? There is a cylinder. Now this cylinder will have a jacket outside it. The cylinder will have a jacket outside it where you can provide the heated steam, right? Through this vessel, see, a bladed rotor is connected. What is a bladed rotor? It is nothing but a rotor with stacking. So there will be a rotor. This is the rotor. It will have, these are the blades. So this is a blade. It is connected at the bottom, right? So through this bladed rotor, a clearance of the order 1 millimeter between the tips of the rotor blade, clearance of 1 millimeter between the tips of the rotor blade and the wall of the vessel. So here you are going to have a gap of 1 millimeter between the tips of the rotor blade and the wall of the vessel. You are going to have some gap. This is the blade, right? This is the rotor, or you can say a motor which is fitted. These are the blades, right? Here you are going to have a distance of 1 millimeter gap, or you can say a free space of 1 millimeter, right? So how it works? As this is a cylindrical vessel, I am showing you the transverse section only. So first of all, you see the liquor which we want to heat, it will be introduced at the top of the vessel, right? and spread as a film over the heated wall by the action of the rotor. So once the liquid will be fitted at the top of the cylinder, the rotor will get start, right? Once the rotor will move, what will happen? The liquid, it will be spreaded throughout the wall of the vessel. The liquid will be spread throughout the wall of the vessel by virtue of the force applied by the rotor blade, right? Next, the evaporation occurs as the liquid passes down the wall. So as the steam is already there, the steam will start hitting the liquid. See, I am telling you once again, the thing is that very simple, don't get confused. I am showing you here only the transverse section. Suppose there is a cylinder, so there is a cylinder here. Suppose this is the top of the cylinder, this is the end of the cylinder. From the top we are going to pour the liquid here, right? It will come down throughout the length. Here at the end you are going to collect the concentrate, right? So when it will come down through the length, the rotor, it will start moving. Once the rotor will start moving, the liquid will get spread to the wall. It will get spread to the wall. It will form a film actually. Thus the vapor is taken out from this tube to the condenser, and concentrated liquid can be withdrawn at the bottom. The evaporator is therefore a form of single tube. Actually, it is a very simple construction, and the falling film evaporator, in which the film is formed and agitated mechanically. Thus, you can say this is a falling film evaporator. Why falling film? Because in that particular cylinder, we have introduced the liquid at the top, right? Now this liquid is introduced at the top, it will come down slowly to the bottom by virtue of gravitational force. But while coming down to the bottom, once the rotor will move, the liquid will get spreaded and it will get attached to the wall of the vessel, and it will form a continuous film, right? As this liquid, it is agitated mechanically with the help of the rotor. The last part here in the evaporation, it is the multiple evaporation, or you can say it's a multiple effect evaporation. What is there? It's a very simple apparatus here. Actually, two evaporators, they are connected in a parallel connection. Thus you can see this is the connection here. This is the first effect. You can say this is the first evaporator, this is the second evaporator. What actually happened here is nothing but, you see the steam, it will be introduced here, right? The liquid will be introduced here. First this chamber, it will get heated. First this tube will get heated. Whatever vapor is formed in this first evaporator, it will be now used to heat the tube of the second one. That tube of the second one will be heated, right? And here the liquid which is present, it will again get heated, and finally the vapor which is produced here, now it will be connected to a condenser to condense the liquid. So it's a simple connection of two evaporators. So two evaporators are connected together with a piping arrangement, so that the vapor from the calandria of the first effect, is used to heat the calandria of the second effect. Here, these are the two evaporators, right? This means that the calandria of the second effect, it will be used as a condenser, for which here, as because it is having it will have no temperature. So whatever the vapor it has produced here, once it will go and reach this part, this calandria, now it will be, this heat of the vapor will be lost here, right? It will act as a condenser for this firstly produced vapor. Whatever vapor it has produced in the first chamber, it will go and move in the second chamber, and once it will enter the tubes here, it will act as a condenser for the vapor which is produced in the first one, right? So that the latent heat, we all know that the latent heat is the efficient heat. The latent heat, it is the steam, they have the latent heat. So the latent heat of vaporization, from the first effect, whatever the vapor it has formed here, it is used to evaporate more quantity of the liquid instead of going to the waste. means it is an efficient one. Whatever the vapor it has produced here, it will be now used to heat the tubes of the second calandria. It will first of all act as a condenser for the vapor produced in the first effect. Moreover, the heat, that is the latent heat carried by this steam, now will be used to heat the tubes here, right? And finally, the vapors from the second one, from here, whatever the vapor it has produced here after heating the liquid which is present already here in this second evaporator, now the vapor which has been produced here, it will be now connected to a condenser and it will get converted into the product. So thank you everyone for your patience hearing. If you like the video, just press the like icon. You can share this video, and for further notification from this channel, do subscribe my channel. Thank you once again.